De Broglie equation. De Broglie, what he says that every matter in this world can behave as a wave. Actually, every moving object is associated with a certain wave, and its wavelength can be given by using the formula lambda equal to h by mb. Here h is Planck's constant, m is mass of that object, and v is the velocity with which the electron or the particle, that substance, moves. For example, suppose he said that an electron is moving at the speed of 5 meters per second, find its de Broglie wavelength. So how it will be solved? Lambda will be equal to h, which is 6.6 into 10 to power minus 34 upon m is 9.1 into 10 to power minus 31 kg, and velocity, that is what we can put anything if we assume it is moving with a speed of 5 meters per second. On solving this, we get the wavelength of the electron, moving electron here. This comes out in meters here. Right. Now, the case is that actually de Broglie wavelength is significant only in case of subatomic particles. In case of larger objects like human beings or truck or car, you can calculate that, but the wavelength is found to be negligible for them. We can show that part also here. Suppose a human is moving with a certain speed normally here. So we take the mass of the human, average mass we assume to be 50 kg, and velocity we assume to be 5 meters per second if he is moving, otherwise 2 meters per second you take. Then you can see that the order of the wavelength will come out to be of the order of 10 to minus 33 minus 35, which obviously is negligible, completely insignificant. This is the value which we cannot even measure up to now. So there is no meaning in calculating the wavelength of bigger objects, larger objects. Subatomic particles, this becomes highly significant, because if we calculate the wavelength of an electron in first shell of Li2 plus ion or second shell of Li2 plus ion, then this value here, mass will be taken as 9.1 into 10 to power minus 31 kg, and velocity if we calculate, this comes also in very high powers of velocity. We have got the formula 2.18 that already we have studied there. If you substitute it here, then this value does not come out to be insignificant. So in case of subatomic particles, this value of lambda becomes significant, cannot be ignored.